Let us get ready for the final exam. Here is a brilliant question on functions, IBHL level. A geometric series has a positive common ratio R. This series has a sum to infinity of 9 and the sum of the first two terms is 5. Find the first three terms. I am Anil Kumar and let us see how do we solve questions effectively. Let me also thank all the viewers and subscribers for contributing by sharing their own problems and learning from this platform absolutely free. Now let's look into the solution of this problem. We are given a geometric sequence. Let's go in steps. That means the terms are multiplied by a common ratio, which is R. And let's say the geometric sequence is AR, AR square, and so on. So the series has a sum to infinity of 9. Now, this formula for sum to infinity is first term divided by 1 minus r. And of course, this series should be a converging series. That means that the value of r has to be less than 1. Absolute value. It could be negative also or positive, but between plus and minus 1. Right. So, of course, it is not 0, then it is a constant, not a series. Great. So, we get this formula, and now we are also given that the sum of to infinity is 9. That means 9 is equal to a over 1 minus r. We can now cross multiply and relate a and r from the first condition given to us. So 9 times 1 minus r is equal to a. 9 minus 9r is a. So we have a relation right there where we have written this particular thing, right? So we related them. Now let's move on to the second condition given to us, which is, let me make some space here to continue. Okay. The sum of first two terms is 5. So first two terms means a plus ar, correct? And that is given to us as 5. So from here, you can always take a common, or you can just substitute the value of a, which is 9 minus 9r in this particular equation, right? So let me call this equation as 1. So we'll sub this in equation which is 2. So let me write down sub 1 into. So the value of a is 9 minus 9r plus 9 minus 9r times r equals to 5. Open and simplify, plus 9r minus 9r square equals to 5. So we get 9 minus 9r square equals to 5 as these terms cancel. Correct. So we can rearrange now. So we have 9r square equals to 9 minus 5, which is 4. And clearly r square equals to 4 over 9. And that gives you the value of r as square root of these. Now, square root will give you positive and negative two values. However, in the question we are given has a positive common ratio. Since the ratio is positive, we'll take only positive value. And therefore, r value is 2 over 3. Square root of 4, 2. Square root of 9 is 3. So we have the value of r. Once you have the value of r, you can always substitute this and get the value of a, right? So we can substitute here. So we get 9 minus 9 times 2 over 3 as the value of a, right? So that is 9 minus, so 9 goes 3 times with 3, 3 times 2 is 6, and that gives you 3. And so we get both the values. So we have a equals to 3 and r equals to 2 by 3. Perfect. So we have found both. Now let's move on to second part of this to find the first three terms. So 3 and 2 by 3. So as we saw there, a is equals to 3, r is equals to 2 by 3. Now we can write down the terms. So the terms are a, ar, and ar square. Right? That's what it is. A is 3. They're multiplying 3 with 2 by 3. Multiplying 3 with 2 by 3 square gives us the terms. So the terms are 3 and this is now 2. 3 square is 9. And then we have, let's work this out on the side. So 3 times 4 over 9, which gives you 3 here, right? So you see 4 over 3, correct? And so we get the third term as 4 over 3. So these are the first three terms of the given infinite series, whose sum is 9, and the sum of first two terms, as you can see, is 3 plus 2, which is 5. Perfect. So that is how we can easily solve this question. Moving in steps and understanding is extremely important so that all the concepts are absolutely clear before we go for the final test. Right? Well, I'll encourage all my viewers to solve more problems from our playlist. You can always like and subscribe, that is great. And be ready for our next lesson. Happy learnings. Thanks for watching. Thank you.